Okay, geometry, video 4, 31 through 40, and this is the last one. Looks like we've got another proof. Given Q is the midpoint of MN, Q is the midpoint of MN. Remember, that means that Q is cutting that segment into two equal pieces. So we would be able to say after that those two sides are congruent. Angle MQP is congruent to NQP. All right? And we're supposed to prove that triangle MQP is congruent to NQP. So triangle on the left congruent to triangle on the right. So without even looking what the proof says or anything, I'm thinking about how can we say that they're congruent. We've got a side, we've got an angle. I'm noticing they share a side, so we're going to be able to say that side equals itself. You always have to say that when two triangles are sharing a side, you have to say that side is equal to itself, and the reason is the reflexive property. So then we have side, angle, side for each of our triangles. So that's where we're going to go with this. Let's see how they lay this out. Q is the midpoint of MN given. Then we have our blank, what we're supposed to say, and the reason is definition of midpoint. So that was what I was saying in the very beginning. I knew that was going to be it because whenever they say something is the midpoint of a segment, automatically right after that, we say that those two sides are congruent. So we are going to say just that. Segment QM is congruent to segment QN by the definition of midpoint. Then we list MPQ is congruent to NQP by given. And then there we see it, QP is congruent to QP by the reflexive property. Therefore, triangle on the left congruent to triangle on the right, which is what we're supposed to prove, and that is by side, angle, side. All right, number 31. Well, I wrote QM and QN, but they wrote MQNQ. Same thing. Letter B for 31. And we're looking for side, angle, side for number 32. Letter C for 32. Good job. Another proof. Isosceles triangle GEF is given. So it's isosceles. So that's another thing where we can say something right after that. If GEF is isosceles, that means it's got two congruent sides. So without even knowing what's going on next, I bet you that is what is going to be said next. And look at that. It's blank. Base angles of an isosceles triangle are congruent. So we're going to be saying those two sides are congruent. Let's read the rest and what are we supposed to prove? GP bisects angle EGF. That's another one where if they say a segment bisects an angle, it's cutting the angle into two equal angles. So we'll be able to say this angle on the left is congruent to this angle on the right. And we're supposed to be proving that EGP is congruent to FGP. Triangle on left, triangle on the right. All right. So GEF is isosceles given. Therefore, we can say EG segment EG is congruent to segment FG. Because the base angles, oh, I'm being stupid right now. Look at that, I made a mistake live on air. Base angles of an isosceles are congruent. My bad, my bad. So not the sides, but they're saying the base angles. And since I already gave those one arc, I'm going to give these guys 2 arcs. Oopsies. So I'm going to revise that. Angle E is congruent to angle F, because the base angles of an isosceles are congruent. Next it says GP bisects EGF, given. Therefore, EGP is congruent to FGP by the definition of angle bisector. Next it says that GP is congruent to itself, GP by the reflexive property. Therefore, the triangles are congruent. EGP congruent to FGP. So we have to say why. What is it that we have here? We have an angle and a side, but then not an angle here. So I'm going to go the other way. Angle, angle, side. Or actually, I'm sorry. Angle, angle, side, to go in that order. So, AAS, angle, angle, side. Number 33, E should be congruent to F, the base angles. And 34, AAS congruence. Letter D for 34. 35, in the diagram, line WY is the perpendicular bisector of AB. Okay, so perpendicular bisector. So that means it's perpendicular and it's bisecting this side, AB. So therefore, AW is going to be congruent to BW. What is the value of x to the nearest tenth? So that's telling me I'm not going to get a whole number. And I can see there are decimals here. So let's figure out what equation do we need to write. Okay. Because we have, I have these two sides being equal, so I would be able to say that this one is also 12x minus 8. And then, so I'm thinking, what, I can't write 12x minus 8 equals 12x minus 8. We'll get all real numbers, obviously. So I'm thinking about what else I can do here. These two, triangle on the left, triangle on the right, share a side. So these two triangles would be congruent with side, angle, side. Since they are congruent, we would then be able to say those two sides are congruent. So that's our equation we're going to be writing here. 7x plus 9 is equal to 4x plus 25. All right, so we're going to subtract 4x both sides. That gives us a 3x on the left, 7x minus 4x. And then we're going to subtract 9 from both sides. 25 minus 9 is 16. And then dividing both sides by 3. 16 divided by 3 is 5.333, repeating. What is the value of x to the nearest tenth? 5.3. Number 35 is D. Use the diagram below to find the measure of angle LMN. LMN. Okay, LMN is this bigger angle, LMN. So I can see we've got congruent triangles here. They're both right angles, and they both have 49 for that leg, and they're sharing a side, which is the hypotenuse. So we've got a side and a HL, hypotenuse leg. So we've got the hypotenuse, and then we have this leg and this leg, HL. That makes these two triangles congruent, the top triangle and the bottom triangle. So if they're congruent, and they're in the right angles too. HL pertains to right angles, right triangles only. So if the two triangles are congruent, then all their parts are congruent. So we could say that little angle equals that little angle, and that's the expressions that they gave us. So we can write 7x minus 28 is equal to 3x plus 22. I'm going to solve this equation. Subtract 3x both sides gives us a 4x on the left-hand side. Adding 28 to both sides, 22 plus 28 is 50. And 50 divided by 4 is 12 and a half. And that's the value of x. So I need to plug it in so I know what the degree measure of that angle is. So 3 times 12.5 plus 22. 12.5 times 3 is 37.5, and 37.5 plus 22 is 59.5. So we've got this red angle is 59.5. The question wanted this big angle, so that would be the 59.5 plus 59.5, or 59.5 times 2 is 119 for that large angle. Woo! That was a big one. All right, 37. Which statement correctly compares the side lengths of triangle LMN? So because we know the angles, we can put the sides in order from smallest to largest or largest to smallest. But we're missing this angle, but that's easy to find out. All angles in a triangle add to 180. So I'm going to go 180 minus 42 minus 78. And that is 60 degrees. So the sides that are opposite the angles tell you the order of the side lengths. 42, I'm just going to start with the smallest. I could start with the smallest or the largest. 42 is the smallest degree measure. So the side opposite it is going to be the smallest side. LK is our smallest. 60 is the next biggest angle out of these three numbers. So the side opposite it is going to be the next biggest size, KM. So LK would be smaller, less than KM, which is less than the biggest side, 78 degrees, LM. Now maybe they might have ordered, okay, they have less than symbols on all of them. So we are going from smallest to largest, but I don't know if they put their letters in a different order. LK is the same as KL, KM is the same as MK, and LM would be the same as ML. So let's look and see which ones. We've got KL, LM, so that one's wrong. LM being the smallest, that one's wrong because that LM is the biggest. KL is less than KM is less than LM. We got it. And this one had KM as the smallest when it was the middle size. So number 37 is C. Number 38, which is the shortest side in the triangle below? This is basically the same question. I've got to find this unknown angle. 180 minus 45 minus 65 is 70 degrees. They want the shortest side, so I look for the smallest angle. 45 is the smallest number, so that's going to make the side opposite it, AC, the shortest side. 38 is A. Which angle is the smallest in the diagram below? So now we're just doing the reverse. They're giving us the side lengths and they want to know which angle is the smallest. So I'm looking for the smallest number, the smallest side. 6.4, 5.0, 3.8 is the smallest side. So that means the angle opposite it is going to be the smallest angle, angle K. Oh, and they labeled it with the letters. So it's either going to be, I could either call angle K IKJ or JKI. Those would be equivalent. And I'm looking for K to be in the middle letter. So that would be letter B. 39 is B. And our final question here. The diagram shows the approximate distances from Houston to Dallas and from Austin to Dallas. From Houston to Dallas, 240 miles. And then from Austin to Dallas, 200 miles. What is the possible range of distances from Austin to Houston? Okay, so to find that third side, when you're building a triangle, the two shortest sides have to be bigger when you add them together. They have to be bigger than the largest side. And so I don't know which one is, you know what, I might have to take a couple of times to do this one. We don't know which of these three is going to be the biggest. So let me think about this for a minute. So say these were the two smallest sides. So 200 plus 240 would have to be a bigger number, and I'll call that X, or they're calling it D, so distance would have to be bigger than D. But so that's assuming D is the biggest side. But what if 240 was the biggest side? Then the other two, 200 plus D, would have to be bigger than 240. So I'm going to take the top one, and I wrote them as greater than symbols. So I'm going to flip this around. D is less than 200 plus 240. And then I'm going to minus 200. That doesn't make any sense. See, I knew I was going to mess up something. The answer is C. So what's wrong? Oh, I know what we're supposed to be doing. I'm sorry. This is what happens when you don't look at the stuff before you go trying to teach it. So to figure out the third side, what we could do is add the two that we do know. 240 plus 200 is 440, and that gives you the max amount that D is allowed to be. And then we subtract those two, the bigger minus the smaller. 240 minus 200 is 40. So that means 40 is the smallest that D would is able to be. So to write that, you always take the smaller number, 40, and it's always less than symbols. So 40 is less than D is less than 440. So you put your smaller number on the left side, bigger number on the right side. So this is saying D has to be in between 40 and 440. And there we go. This first one just doesn't make any sense because you would never have a distance that's a negative number. So that one doesn't make any sense. Letter B doesn't make any sense either because of 0. You wouldn't have a side of a triangle that's 0 miles long. And then as far as the other one, I think those would just be two. You could have numbers smaller or bigger than either of those just to build a triangle. So this is just something you have to memorize about the side lengths of a triangle. You can take the sum, and that gives you your bigger end, and then take the difference, and that gives you the smaller end. And that is it. They're going to give you graph paper too. That's what's on the end here. And that is it for our videos.